Hi everyone, welcome you all. In this video, I am going to explain Coulomb's law. What is Coulomb's law? Before we see the Coulomb's law, first of all we should know what is electric field and what is line of force. What is electric field? A space around the charge is always under stress and experiences force on other charges when placed there. The region or space in which stress exists is called the electric field. The stress in the space is represented by line of force. Then Coulomb's law. When two charged bodies are placed near each other, a mechanical force experiences on them. According to the Coulomb's first law, charges of same nature repel with each other and charges of opposite nature attracts with each other. According to the Coulomb's second law, the force between two charges is directly proportional to the product of the charges, inversely proportional to the square of the distance between them, and depends on the nature of the medium surrounding the charges. So it is F is equal to Q1 Q2 divided by 4 pi epsilon into R square into R. R is R cap, that is the unit vector. And see here, what is Q1 Q2 in the numerator? Q1 and Q2 is the product of charges. What is R square? Square of the distance between them. And what is R cap? That is the unit vector. Here, K is the constant of proportionality and K is equal to 1 by 4 pi epsilon naught. Q1, Q2 measured in coulombs. R is measured in meter. F is measured in Newton. Epsilon is the permittivity of the medium, that is epsilon naught into epsilon R. Epsilon naught is the permittivity of the free space. Epsilon R is the permittivity of the medium related to free space. For free space, what is epsilon R? That is equal to 1. What is epsilon naught? 10 power minus 9 divided by 36 pi. That is 8.854 into 10 power minus 12 farad per meter. Now what I have to do? I have to substitute this 10 power minus 9 divided by 36 pi in the equation K. So I get the answer 9 into 10 power 9 meter per farad. Next we are going to see vector form of Coulomb's law. Let the vector R1 locate Q1 while R2 locate Q2. Then the vector R12 is R2 minus R1. That represents the directed line segment from Q1 to Q2. Vector form of Coulomb's law is F2, that's the force on Q2 is Q1 Q2 divided by 4 pi epsilon naught into R12 square into A12 cap. A12 is the unit vector direction of R12. So A12 is R12 divided by R12 modulus. So what is R12? R2 minus R1 divided by R2 minus R1 modulus. See, this is Q1 that is located in the distance R1 from origin. Here this is R2, Q2. So what is R12? That is R2 minus R1. What is A12? Unit vector directed from Q1 to Q2. So this is the force on Q2. If Q1 and Q2 have like signs, the vector force F2 on Q2 is in the same direction as the vector R12. Okay, next see the problem. Let us illustrate the use of the vector form of Coulomb's law by locating a charge of 3 into 10 power minus 4 Coulomb at m of 1, 2, 3. This is the location. And the charge of Q2, the location is n of 205 in a vacuum. We desire the force exerted on Q2 by Q1. On Q2 by Q1 means we are going to find out R12. So what is R12? R2 minus R1. So already we are having R2, that is 205, and what is R1? 123. So 2 minus 1 into I plus 0 minus 2 into J plus minus 3, that is minus 3 plus 5, or 5 minus 3 into K. From this we get I minus 2J plus 2K. So I is the unit vector along x direction, J is the unit vector along y direction, and K is the unit vector along z direction. So to say A12, R12 divided by modulus of R12. Here R12 is the vector. What is modulus? Square root of 1 plus 4 plus 4, that is root 9, that is equal to 3. So what is the force on Q2? F2 equal to 3 into 10 power minus 4 into minus of 10 power minus 4 divided by the value 4 pi epsilon 0 into r square, r equal to 3, I plus 2j minus 2k divided by 3. Now I have to multiply and I have to cancelling these values. Finally I get the answer minus 10 of I minus 2j I minus 2j plus 2k here, not minus 2k, here I minus 2j plus 2k. So what is F2? Force on Q2 minus 10I plus 20j minus 20k. So this is the force F2. Thank you.